Hello? Oh. Okay, hello everyone. Sorry for the room change today. The department had a little mix-up, I guess, and scheduled an exam in our usual room. So we're here. But yeah, so today we have a couple of things. To get attendance, you can go ahead and fill out this form. It's also posted in the Slack. So you can just go ahead and click on the link there. And the code word is going to be ECV. ECV, as in the building. Okay. All right, the second thing is...
All right, so the other form is the excused absence form. So if you emailed me or Slacked me or talked to me about missing lecture or something, just fill out this form. I'll put it in the Slack after lecture, and so that way we can keep track of your absences better. Because I realize that there's 200 of you and I get 600 emails, so I don't want my inbox breaking. So let's. I'll put that form in general right after, and then you guys can fill that out. But yeah. All right. Also, homework 2 I think is officially closed now, and homework 3 will be out tonight. As usual, we have a week to do it, and we'll have office hours on Friday and Monday, and it will cover a bunch of stuff that the learner will go through in lecture today. Also, next week we will have Python, but we'll also have a lecture from our sponsor, IMC. IMC is like a trading firm in Chicago, and they do a bunch of cool stuff, and they've supported this class from the very beginning. So I'm sure you guys will have a good time hearing from their engineers about kind of the things they do there, and there may or may not be free T-shirts and stickers and water bottles. So make sure you come for that. And then, we'll have our actual classroom back next week. So, awesome. So we'll do Python first, and then we'll have a micro lecture on code style and testing. So, awesome. All right. Can you all read that? Awesome. Sweet.
Okay, so last week we talked about lists, and basically, someone just give me a summary of what a list is. Yes?
It's like an array, like an array of values.
But what is an array?
Which is basically like a set of values, that's organized in a single unit.
Okay, yeah, that's a good description, right? So a list in Python is basically an array, and so it has indices, and then you put different values there. And then it's a way to organize it, right? So you could have a list, let's say, of numbers like 1 through 10. You could have a list of all sorts of different things. And it can be any type, right? So today we're going to extend that idea, and we're going to talk about multi-dimensional lists. So these are super important. Like, this is something that you'd actually need to know to go out and code in the real world. And so what do you think multi-dimensional arrays are actually used for in real life? Yeah. Images? Yeah, that's a good point, right? So when you go on to take 225, you're going to do a lot of image manipulation, and you store each of the pixels in a spot in a two-dimensional array. So if you want to picture that, you can see in a picture, there are rows and columns, right? And each of those, you can index each pixel by picking a row and a column. So that's an example of a two-dimensional array, but we can use even more. What would be an example of a three-dimensional array? Sorry, list. Does anybody have an idea? I see hands. Oh, wow, okay, yeah. Yeah, exactly. So, that's definitely a thing. I remember freshman year, they showed us this thing that was in Amazon, they have automated robots in the warehouse, and so you need three-dimensional coordinates for that because they need to move and then pick things up. There's 3 dimensions, right? Yeah.
If you want to store a lot of tic-tac-toe boards, for example, if you're playing ultimate tic-tac-toe, then you would want a 3-dimensional array, probably.
Was this like a 126 MP or something?
No, I'm in 125.
Oh, I see. Okay. Yeah, okay. So basically, multidimensional lists are just a way to organize more data, right? So if you got that picture thing from here, didn't you? It says that right here. Or maybe not. But anyway, yeah, so you can see right here, we have a list. So the way that we define it is we have, like, these brackets define one list, right? And then within that list, you can see we have 3 sort of sub-lists here, right? And so in Python, is it 0 index or 1 index? 0, yeah, I'd be scared if you got that wrong, but yeah. So 0 index, so we have the 0, the first, and the second indices here. And then within those, this has its own 0, first, and second index. So basically, if you think about it that way, it's sort of easy to figure out how to access the element that you want to get. So here, let's run this first, and then we'll run this, and you can see that was the output, right? So when it prints it out, it looks like this, right? It's sort of flat. Like, this is what we might imagine it to look like, and if we wanted to think about this like a square, because that's sort of what a 2D array is conceptually, then we can see it like this. But when it prints out like each row. Okay, and then what do you think we're gonna get when we print out this x of 0? Everyone's really quiet. Yeah, you can shout it out.
1, 2, 3.
Okay. Yeah, and that's right. So basically what it did here is it just accessed, it went to the list, and the list is x, right? And then it accessed the 0th index. So is anybody confused about why that is? It's totally okay to be confused, because this is pretty tricky at first to understand. Does anybody have any questions? Okay. Okay, so then what happens when we do this? Right, okay. So you guys have a pretty good grasp on that. Are there any questions? Okay. Okay, so one thing is when you're actually writing these, so this is like a super simple example. This is like an example that's made up purely for the sake of this class. But as you progress through your classes and then you go on to the real world, then you'll see like way more complex examples, right? So you might not have like 10 things in the array. You might have like a million things in the array, and each of those has like a million. Each array or each index in the array has like a million of its own items, right? So you might have something that's just huge in size. Yeah. So basically, you can't always just go set the values by hand. So what is a way, like you can sort of see, I like scrolled down, but well, how can we actually like do this fast? Like let's say I have a set of values and I just want to put them in the array. And I've got like a 2-dimensional array. We're gonna use a loop, okay, good. So how many loops? Like raise your hand if you think we're gonna use 1 loop. How about 2 loops? 3 loops? What if you're just, raise your hand if you didn't raise your hand? Nice, okay. So anyway, yeah, so we're gonna use a couple of loops to do this. So I want somebody to come up here and explain this, like line by line. Yeah.
I use the top word.
Yeah, sure.
So we can just go through this line by line, so we can like figure out what's happening. So first, I'm just gonna be putting what my list is. So my list is just this at the start, and then it says for x in range 0 to 3. So what we're doing now is like x. We're gonna go through the loop 3 times for x equals 0, x equals 1, and x equals 2. So when x equals 0, this is our first time through the for loop. Then we're appending an empty list to my list. So appending just means we're adding the element to the end of the list. And right now the list is empty, so that just means we're putting that into the list. So we're appending an empty list onto our list. So now we appended a list into our list, right? And then now we're going through the inner for loop. So for y going 0 to 3, my list of 0 is getting appended, like count is getting appended to that. Right now count is 1. So my list, so this is like my list 0 is the thing on the inside because it's the 0th element of my list. And then we're appending the count to that, and count right now is 1. And then since that list is empty, we're just gonna put 1 into that. And then now on the second time through the inner for loop, the loop for y, my list of 0, which is still the inner thing, is gonna have count appended to it again. But since count got incremented, now count is 2. So we're appending 2 to the inner for loop. And similarly, on the third time through the inner for loop, 3 will be appended to the inner for loop. So now we've gone through the inner for loop all 3 times, and we're ready to go through the outer for loop the second time. So now we're doing x equals 1. And then my list is getting appended again, and then this time we're appending another empty list to that. So now we've appended another empty list to that. So now my list has 2 elements. The first one we've already filled out, and the second one we just added because we appended an empty list to my list. And then now we're going to go through the inner for loop 3 times again. So we're appending the count to the inner list. The first time we append it, it's 4, 5, 6. And then the last time through the for loop, you get the idea. It'll add another thing into it. So that in the outer for loop, you're appending another array into it. And then the inner for loop like appends the count to it again 3 times, and then the count happens to be 7, 8, and 9 for those 3 times. Does anyone have any questions? Yeah. Sorry if I took too much time.
Oh, that was okay, yeah, so basically that's what it does. You run this. Yeah, and that's what you get. Okay. So is there any confusion about this at all? Yes.
How does Python work with like empty lists? Because I kept having a problem where if I only initialize it with the bracket, it's
So if you only initialize it with a bracket and then try to access like an actual index, then the index doesn't exist yet, right? So it's different here because we're using append. So it's just saying add it to the end, right? So it doesn't have any problem taking an empty list and putting something at the end of that, right? But it's gonna have a problem if you take an empty list and say, okay, put like 8 at index 100, because index 100 doesn't exist. So does that answer your question?
yeah.
Okay. Okay, any other questions? Yeah.
If you have an empty list, can you put something at index 0, or can you only append?
So if you have an empty list, you don't have any space at all. Having a list having a list that's just empty is not any space. Like the 0th index is space for one thing, right? Okay, yeah.
Why can't we append at my list x if it was empty?
So that's what I was saying. So there's a difference between appending and actually accessing an index, right? So if I say like my list at some value, it's not gonna work, right? Because it doesn't know that there's space for that. So like, let's say this was like a super low level language, right? I would have to actually allocate space for the list. And if I didn't do that, then I can't access that because there's no memory for this, right? So if I make an empty list, it doesn't have memory to actually put something in, right? So yeah, but when you do append, that's like telling it that make space for like one thing and put that element there. And so like you can keep appending things, like it can be like 100 elements long, you can keep appending, but that's what it's saying. Does that make sense? Okay. Are there any other questions about this? Okay. Okay, so now we have another one. So we were just looking at integers before, but now we're going to take a look at strings. So I have this list called shopping list, and I have new items, right? right? So let's say like I have an app that is a shopping list app, right? So I'm sure someone's done this in the past in this class, basically having like a to-do list or like a shopping list, something that you want to add items to. We have a list, and then on each line we have like different things, right? Okay, so I want to add a new line. That's these 3 ingredients, right? So maybe this is like for a specific recipe. So let's see. So I'm going to append it. What is it going to look like when I do this? So this covers just what we just talked about, like what append does. So what are we going to see? Like someone different answer this time. I'm going to be forced to call on somebody. You guys, you haven't answered. Okay, so like what is it actually going to look like though? Where am I adding? Like I could just be adding it to the beginning. Yeah, exactly. So it's going to go on the 3rd index. And because we use append, it's making like a space for that. So now your list is going to be, it's going to have length 4, right? So length 4, and it's going to have indices 0 through 3. So when we do that, and then we see what we get here. Yeah, you can see that's exactly what happened, right? So yeah, so you can see this is pretty powerful, right? Because like there's so many things you can hold in arrays, and there's so many things where it's like super important that you actually like can store like corresponding values. So like I said, 25, you do a lot of this stuff. Like you'll do this like in every class. Like I'm thinking in 241, you use arrays to store like pointers. You guys don't know what pointers are yet, actually, but you use like arrays to store characters. So strings in C, if you want to change them, you have to put each character into a separate spot in an array, and then you can go ahead and change them. So you can see like you might not have to do this stuff in like a high level language like this because someone's implemented all this stuff for you. But as you go like into lower level languages, you see that all of these like structures are really important. Yeah, actually on that note too, so if you run something on the command line, so if you have like your program and then you run it and you have arguments after it, like you need to put in some input to get the program to run, like a file name or something, that will come in, like if you're dealing with C, that's gonna come in an array too. So that's how you would get those off the command line. That's like sort of advanced, like you don't need to know that, it's just interesting. Okay. Okay, so let's not look at that yet, but I'll ask you guys. So if you wanted to figure out what the dimensions are, how do you think you would go about doing that? Yeah. Yeah, so like the length function will get you, like we talked about that last week for a single list, right? So if you just enter like the list itself, you're gonna get the number of indices, right? So like let's look at this one really quick. So here we go, right? So this had, what's the length of this? If I just say length of shopping list, or like 4, right? Yeah, so because there's 4 indices, right? But what if I say length of shopping list at 3? Yeah, that's an easy one, they all have 3, don't they? But yeah, you're right, because it's coming from this one, right? So it's indexing the list itself, and then it's gonna go into this index. So yeah, you can see here, if you wanna get the number of rows and columns, you can do the length of the list, and then you can do the length of the list at a particular index. So it sort of just depends how you wanna think about it. I don't really think about them in terms of rows and columns anymore, but you can think about it that way. So does that make sense to anybody? Everybody, not just, does that make sense?
Yes.
That is an enthusiastic yes.
Yes.
Okay. Okay, so what do you think we're gonna get here when we print this out? Oh wait, yeah, actually, X was all the way up here. Yeah, so it was just the double array that had the numbers like 1 through 9. So you should be able to figure this out. Yeah, right? That's pretty simple. What if I do something like this, though? What if I don't like this list anymore because it's super boring, and I go ahead and add, let's see, I'm just going to add, so that's syntax okay. So do you see that change? Does that make sense? Okay. So it changed because I changed that index, right? So I changed the length there. Or sorry, I added an index to the original array. So that's why it's 4 rows now. Okay. All right. So what I just showed you there is basically a jagged list. It's not like all lined up nice and pretty, right? So it's sort of easy to do math when like everything is the same number of indices, right? Because then it's like we can just go through everything, and it's really simple. But here we have list, like it's called a jagged list. It's just like when you don't have the same number of elements in each thing. So you can see here, like we have three elements here, and then we have 2, and then 1, and then 3 again, right? So I'm gonna run this. So what are we gonna get when we run this? Okay. Now, what are we gonna get? What are we gonna run when we get the next one? I wanna hear from someone you knew. Somebody in the back. I am going to pick on somebody. I see you in the yellow shirt. Yes. What do you think we're gonna get for this one?
Is that X?
Yeah, that's X. Or it's called jagged X.
6.
Okay. So we actually get 8, right? Because we're accessing the third index, right? So 0, 1, 2, 3 here, and then we want the first index here. So yeah, that was close. Yeah, so when you're doing this, it can be easy to make off by 1 errors. So you want to make sure that you pay attention to what you're doing. Remember that it's like 0 index. Okay. All right, so the last thing we're kind of gonna go over really quickly. We'll have a different lecture on this later that's gonna go over this in depth, and we're actually going to have someone come in and talk to you about algorithms and like runtime, and someone who knows way more than me. So there's whole classes on this. You'll take like 173, 374. And it goes on and on. You just keep taking classes in theory. But basically, big O is just runtime for a function. So does anybody know what that means? I want new people to answer. I'm sorry, you guys are really smart, but we need more people to answer. I guarantee the longer we wait, the more awkward it's going to get. You can be wrong, it doesn't matter. Do you know, like, just the runtime of a function? What do you think it is? Just throw something out again. What'd you say? Okay, yeah, so it's sort of in that vein, right? So it's a way to, quantify how complex the function is and how long it's going to take to run. So basically, you can see we used loops in this lecture to populate a 2D array, right? So that's called O of n squared. And why that is because we have n elements in our list, hypothetically, right? So if I wrote that function and I gave it to somebody, right? And I don't know how many elements they're gonna pass in, right? Like I don't know how big of a list they want. Then that's like n, that's like our unknown, right? But I do know that for n, if I wanna go through and like make an array like this, and let's say I'm going from 0 to n here, that's like the key point, right? So I don't have a constant, I have n. And I'm not gonna know n until somebody passes that into the function and says, make me an n by n array, right? So that's gonna be n squared. And so you guys might not super understand that right now, that's okay because we'll go over it later. But that's basically what that means. So like extrapolating that, what would a 1D array, how long would it take to go through that, given like n arbitrary elements? Yeah, back there. Yeah, exactly. So it's going to be O of n because we're just going through n. And now, okay, so like extrapolating this even further, what are you going to get if we just say, what is the runtime of this? This line, yeah.
It's just constant.
Yeah, it's constant time, right? So it's O of 1. That's perfect. So it's okay if you don't like completely get this. Like if you've taken a CS class before, you might get this. If you haven't, that's totally fine. So you'll like slowly come to understand this, and then you'll see all the variations. So you can do like, yeah.
Is this like only like applied to like groups and like arrays, or can you apply like to other functions?
No, so this is like a general CS concept. So any given piece of code you can look at and say like, what is the runtime of this? It's like a typical interview question. Like a lot of times they'll ask you like, like code this, and they'll say like, what is the runtime? So like there's a lot of different things you can do. You guys have not learned recursion yet, right? Okay. So like recursion, you can look at. Have you guys learned how to do like binary? Anything? Okay. That's okay. You guys will get there. But there's all sorts of different runtimes, and you'll learn about them more as you go along in your classes. Let's see, what else do we have here? Okay, I guess a little bit more with this. So if I have, let's say, a loop that goes through, like the loop we were just looking at, right? Goes through n times, and then for each of those n things, it goes through n more times, right? So if I do the stuff that I do within this, like if I do extra stuff here, like this count plus 1, this is just constant, right? So like officially, like mathematically, if you wanted to figure this out, you would like write down, like you figure out what sort of like each part is doing. So you'd be like, this is n, so we get n squared. But all of this stuff, like this is not actually like taking, this just takes constant time, right? So what you'll end up with is like an equation that has both like, it'll have both like n and some constants and stuff. And so you just take the biggest term for big O. So even if you end up with something like big O of like 3n or something, usually we don't care about the coefficients, so we just take like, it's just big O of n. So yeah. And the reason for that is it doesn't really matter once you get past a certain point. So as that function grows with the size of n, we don't really care what the constant is. It's always going to be bigger than like other types of functions. Okay, so are there any questions about that? Okay, so if you're confused, that's okay. I would like take a look at this. I would like Google and probably like read about this, but you'll definitely come across it again. You'll come across it in 173 for sure, and all of the algorithms classes after that. So hopefully in this class you'll get a good foundation after we do like another lecture about this, and we might have some questions on the exam or on the homeworks to like really solidify this. It's good to know this early because it's a really useful thing, and it'll become more intuitive. Okay, so we're done with Python for this week. Does anybody have any questions about like homework, Python, anything Python related or homework related? Yes.
And some of the old homework assignments, I wasn't sure if I was right or wrong, whether it's right or not. But for number 2, it actually gives us feedback on whether, okay, it achieved all, like, it gives, like, oh, you got 100% of the test right. Whereas before it didn't. Are we going to always see, like, the whole, like, what percentage of the test we got right?
You should see that. I mean, that's like a technicality with the homework team. They're probably getting things ironed out. But yeah, you should definitely see how many tests you pass so you can figure out, like, what you need to change. But yeah, that should be on future homework. I mean, you guys are going to stop using Relate soon and start having actual like assignments that you push to get, so it shouldn't be a problem. Okay, anything else? Okay, so homework will mostly be weekly. There's going to be a couple weeks where you don't have homework, and then the homework will stop like around halfway through. So I don't know the week number off the top of my head, but it definitely stops because we want to give you guys time to work on your projects. We don't want to take that time away from you. Okay. Yeah.
Is there any like timeline for when the midterm?
So the midterm, do you know? Yeah, it's going to be around Thanksgiving. It's basically like the middle of the semester. So we schedule things so they don't overlap too much. So like your midterm presentations for your projects won't overlap with like the midterm week, and like homework should be lightening up / done at that point. So yeah. All right. Anything? Yeah.
What percent of our grades is the homework?
I'm sorry, what?
What percent of the grades is the
What percent of ways is
Okay, I cannot hear you, but read the syllabus. That is.
Where is the syllabus?
The syllabus is on the website. Thank you. The syllabus is on the website. The syllabus is also on Piazza under important resources. So if you go there, it's a pinned post. You can find it there. You can find all of the resources there. Okay. If there's no more questions, I'm gonna hand it off to Prithvi, who's doing coding style, and let's see if I can get the slides up. Okay, yeah, so coding style and testing.
In regard to the homework, starting this week also, we're going to no longer let you test whenever you want. We're going to have scheduled auto-grader runs, so just a heads up for homework. So it's going to be more on a schedule. But you won't really need the auto-grader because we're going to talk about testing today, so you're testing your own code. Okay, so the first thing is, what is coding style? So coding style is basically how you name your variables, like how much white space you put in, how you structure the code. So like if you split your code up into several methods, and so what like that. It also covers magic numbers, and I won't necessarily cover magic numbers in this lecture, but basically what a magic number is, say you're like subtracting 65 from a number every time. You shouldn't do minus 65 each time in a for loop. You should store 65 in a variable so people that are reading your code know what 65 is. So once you do that, and it also encompasses commenting, so make sure to comment your code so people can understand it. This is especially important in Python where your variables don't have static types, so people know what your variables are doing and you're not like radically changing what you're using the variable for every time. So good to comment your code. So why is it important? One of the reasons is debugging, so it's easier to find a problem if your code is nice and neat. That's one reason to have good code. Also, it's easier to read and it's easier to understand if someone else is trying to read your code. So if someone else is trying to read it, if your code is all messy, it's gonna be harder for them to understand what's going on. So making it neat is important and making it understandable and using good style. It's also more professional. So if you go on to have an internship or a job, they're gonna want you to make code that is not only looks nice, but also other people can understand once again. Another aspect in terms of making it more professional is that if you're in a code interview and you don't know how to solve a problem, for example, or you don't have enough time, if you employ good coding style and good commenting and you explain your thought process, you might still pass the interview even though you didn't get the problem right. And that's happened to me before, so good coding style can be a benefit. It's not just something that takes a lot of time, unnecessary time because you just have to take time commenting. It also is beneficial for yourself. If your code doesn't work for some reason, but you explain your thought process, someone else can find the error for it. So we have a piece of code right here. Can anybody tell me what's wrong with this code? Like what this code is doing right here? Yeah, okay, so it's really hard to tell what this code is doing. And as you can see, the variables are just letters and there's no comments, so can't really understand what's going on here. Let's try adding some comments. Now, here it's a binary search, so it's searching through an array to find an element, but that's a lot of comments right there. The variable is still named A through G, and it's still really hard to tell what's going on, right? So this is basically showing that comments are not really a substitute for good variable names. You can have comments in your code, but if you don't have good variable names, it's still confusing, and nobody really wants to read just a wall of text when they're reading a program. So if we fix our variable names, it's a lot easier to understand what's going on now. But all those comments still take up a lot of space, and it's still not really very pleasant to look at because you still have all of those comments, and a lot of them are really redundant at this point because those variables explain what they're doing in their name themselves. So it's really important to have good variable names because you can reduce any time it would take you to comment the code by just having a good variable name. If the variable name itself explains what the thing is doing, there's no need to have a comment there. So I would argue that this is a better option right here. To explain what the code is doing, I just linked to a Wikipedia link. And with good coding style, with good variable names, it's easy to tell what's going on, what corresponds to what from the description of the problem that I provided. So ideally you want to comment like this. If you want, you can have 1 or 2 comments in there if you would like. Or you can even separate out the doc string, which is like the documentation for this at the top, into a different file. In many companies, if you're interning there, such as Amazon where I work, they have a no commenting policy, so they don't want to see comments in your code because the code should speak for, that's not because they don't want anybody to understand it, it's that the code should speak for itself, because if like someone can't look at your code without you standing next to them at all times and understanding what's going on, it's not really going to be very scalable. So although comments sometimes can be used as a crutch for bad code. So say people just like write like a 30-line comment as to what something is doing, rather than just making the code more readable. It's not really a very good practice. So it's always a good idea to first write code without comments and seeing if the code can speak for itself and if it's easy to understand what's going on, and then add comments if they're really necessary later on. So good to write good code here, and once again, it's really beneficial in terms of debugging your code. So if you have a problem and you have good variable names, you can say, oh, the problem is with the higher bound variable, higher index variable, or something like that. So next thing is coding layout. What is this? Is this method doing too much? This is a method from your homework that you could have used, I guess, to find if something is a palindrome prime. It's doing a lot in there, like first figuring out if it's a prime, then you're finding out if it's a palindrome. And this is really doing a lot. For those of you that take 126, you guys would have learned to make your code modular. So that's splitting up into methods. So like this here is doing 3 different things at once. First it's seeing if it's prime, then it's seeing if it's palindrome, then it's checking if it's both. So that method is really doing a lot at that point. So you probably want to split this up into several methods. And when you split up into several methods, it's once again, you wouldn't need as many comments because it's easy to tell what each individual method is doing. So splitting up into different methods is really good practice. Another thing is, this is also something that you guys should definitely employ into your group projects. You don't want to just have like, when you guys submit your, are done with your project, you don't want to just have one giant method that has like 3,000 lines of code as your entire project. That's just, nobody's going to be able to find any problems with that, and nobody really is going to want to add anything to that either, because they're going to find where in those 3,000 lines of that one method, they're going to be adding stuff. So make sure to split it up into methods. Each method should be doing one thing alone, if it really needs to be 2. Make sure that those 2 things are closely related, but in general, make sure to split it up into several different methods. So each thing is only doing one, each method is only tasked with one thing. So make sure to employ this in your own group projects that you're going to be working on over the course of this semester, but also in general, like if you're in a coding interview, make sure to still be modular, even though they ask you one question. If you can show them that you're commenting your code well, and you're splitting the problem up into different sub-problems, they'll be really impressed by it, rather than just trying to submit one giant method that's just like brute forcing everything. So that's basically it for coding layout in general, or coding style. So now we'll move on to testing. And as I said earlier, starting this week, we're going to move to an auto grader that runs once on our schedule, not whenever you want it to. So it's really important now for you to test your own code. And the purposes of testing would be to find bugs, obviously. So if you test your code and it doesn't pass, find a bug. And it's to ensure correctness. So a lot of people have been asking on Piazza as to why they can't see all the test cases. And I want those people to just like imagine a scenario where their boss asks them to write a program for something. And then you respond to your boss, okay, tell me every single thing you're ever going to use this code for. Your boss would just kind of stare at you and be like, why did I hire you? So in general, you want to make sure that like your code works. You shouldn't be designing your code just to pass the test cases that are provided at that current time, because there could be new problems that your code should be used to solve, and people shouldn't have to revisit your code to fix it because it only solved a certain number of cases. This is especially true with the autograder, because if we just told you all of the test cases, people could just hard code the answers saying like, if the input is this, return this, if the input is this, return this. And that's not what we're looking for. We're looking for code that'll work regardless of what the input is. Another important reason to test it, especially in Python, or in general I guess, is just to make sure that it's efficient. So I'm going to cover here different types of testing. But I know a lot of people on Piazza, for example, were complaining that their code timed out, and that's because they weren't really testing their, we were testing efficiency of the code as well, so making sure that the code was ran fast enough and didn't take like over 30 seconds to run on a large input. So it's really important to do that. And as I said, you don't have to wait for the autograder to run if you tested your own code, so no waiting. You can run it on your own time. So how many of you have written test cases in Python before? Okay, so I'll cover that as well later on here. So different types of testing. You have unit testing, which is just testing one method at a time. So that's just testing a small bit. You have integration testing, which will test how different methods interact with each other. And so it's going to be testing, say one method calls another method, you'll be testing both methods in that case. And there is end-to-end testing, where you're testing from like how the entire product functions from start to finish. So like if you have a UI for your product, you would see some things that we put it into the UI and how it responds, make sure that it responds everything correctly. This could be done manually rather than automated. Integration and unit testing normally want to have automation, but end-to-end testing, sometimes it might be necessary for you to do it manually. Like if you have an app, make sure that all things are running properly if you test it with your own inputs. And you have performance testing, which are like load tests and stress tests. So that tests how efficient your code is. So for extremely large inputs or edge cases, making sure that it runs properly in a good amount of time, because you don't want to be sitting there on a website that you created, waiting 30 seconds after you click a button to give you the result. That's just not a very pleasant UI experience. So you want to make sure that you have performance tests. So first thing is code coverage. I have a method here to tell if a number is even, and I have some test cases. If you run these test cases, they all will pass. So if I had just written these test cases using assert statements, which is how you would write test cases in Python, I would think that my isEven function passes, but it evidently doesn't, because odd numbers cause errors, and that should have been caught by the test cases I wrote, but I wrote bad test cases in this scenario. So that's why it's important to have good code coverage. And code coverage can be classified into two different things. You can either have line coverage or branch coverage. Line coverage is, and a lot of the time in Java, for example, which you guys are taking 125 in, learning in 125, if you create your own JUnit tests or anything like that, it'll tell you what the code coverage is. So it's important to tell you line coverage as the number of lines of code that executed over the course of your test cases, or branch coverage, which is like different branches that were taken. So in Python, there's not really an efficient way to do that because you're not really using an IDE, but in Java, you can just easily tell what percent of the lines were covered. But in Python, you can see here, all these test cases would pass, even though this method is not valid. So make sure to test your code and test all the different possible branches that it could take, and make sure it's covering everything. So now we move on to performance testing. So this goes along with the previous statement that I made about the homework, how a lot of people were complaining that their isPrime or palindromic prime functions were timing out. That's because we were using performance tests. So like, as you saw on the bottom, these aren't the exact tests we were using, but these are extremely large numbers, they're prime numbers, and I'm testing to see if they're prime, and if your method took over like 10 seconds or so, it was too inefficient, and as a result, it would not have passed the test cases, because we can't let your method just run forever, because that's a waste of power, because we can't tell if it's any further over. It's just gonna run and never find a solution. So we have a timeout on the homework, so that's why it's important to have your own performance test before you submit code. And you guys will learn this also as you go along into different classes, to make sure to test your code. It's not just for this class that we're gonna have like a timed auto grader going off of this. You'll have a timed auto grader, and you'll be asked to have your own test. Every class in the future, you won't be able to run tests at your own time. You'll have to wait for an auto grader. So this way, using unit tests or performance tests, you can test it on your own time. You just have to write them, which can be tedious at times, but it's better that you find a problem than an auto grader or your boss finds the problem. So that's why it's really important to have these, and especially test them with large inputs. Because if you don't have a performance test, you can just be testing them on small inputs and just like validating your own belief that your method works. But your boss is going to test it on some huge input, or the auto grader is going to test it on some huge input, and they say, oh, I didn't think it would do that to us. I'm like, okay, that's your own fault. You should have done better testing. So make sure to test big inputs. And the last thing here is edge cases. So edge cases are often the most important. These are like the fringe of inputs or outputs. In Python, for example, because you don't have strictly defined types, if your method takes in 2 integers, I can pass in a string if I wanted to one of them, and your method would just crash because you didn't code to test if your inputs were strings, which in this class you won't have to, but in the future, just make sure that a user can't put in bad inputs. Or like, so you're given a problem with an array, but you're given an empty array, or just none, which is just a null, so nothing at all. Make sure that your test case functions with that. This also encompasses, to an extent, performance tests, so extremely large or extremely small inputs, making sure they work. And as I said, these are the most important because this really shows that you took the time to understand the problem rather than you just coded it just for the majority of solutions, you coded it for all solutions. So these are the most important tests to make sure that you test the fringe cases. And that's basically it on testing. Thank you. Does anybody have any questions? Yeah. 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 Oh, okay. So that's a main method in Python. So that's just So if you work with Java, you have public static void main. That's what this is in Python. So that's a main method. So when you execute the Python script, by doing like Python, whatever the name of the script is, that main method will run. Yeah.
For splitting up, so the functions, is there a performance hit calling another function instead of
No. It's Python is going to interpret the same. So you should do it. Split it up into several functions just so it's easier to isolate a problem. If you run unit tests for each one of those individual functions that you broke it up into, and you have a problem, this way you can isolate exactly where the problem occurred. So it's not just that it looks nicer and it's smaller blocks. It's easier to isolate a problem by having more modular code that's split into several methods. Yeah.
Are there any pieces of test code that we should be looking at as to get an idea of what we might use for our own testing?
Okay, yeah, so as I said, like, here you can just, in Python, it's just assert. So what this assert method basically does is that it asserts whatever that you put into it is equal to whatever is after the equal sign. And if you call this method, it'll just it'll return correctly if all the test cases passed, or just completely fail if it didn't. So the test cases are more based upon, like, you can look it up, I guess. Also, for more detailed test cases, these are just relatively simple tests. So it's just checking if I run it with a certain input, assert, and make sure that the value that I specified is equal to the two values, and if it isn't, just end because for the way this works, at least in this example right here, is that it'll try to run all of these test cases, and if anything happens in the first test case, it just won't even bother running the other test cases, or in some cases it will. It'll just tell you that this test case failed, and it'll tell you the exact line where it failed in Python, and it'll say, okay, so it failed on this input. So that way you can try to find out what's wrong with it. So assert is how you do it in Python. In Java, you can use JUnit tests. And yeah.
For assert, is there like a way to input? Is there a way to input a message that you know basically which one you know?
Yeah.
Or
So
just
yeah. So you can input it if it fails. What you can do, I guess, is you can tell it what you want to say. But in here, it just like the program will crash, at least in Python, and it'll just say assertion error. So if I tried to run this and those type cases didn't pass, it would say assertion error, and it would say what the search statement is wrong. You can also tell it a message that is wrong. You can tell it that, oh, everything failed here.
and that would be input like to a prime number, or is that like where would you put the
For that, I guess you can try to put it in, like, if you wanted to, like, not exactly sure exactly how assert works. I think you can specify a message, or you can put it in a try catch and catch the assertion exception, which you guys haven't done try catches, but you can catch that assertion exception and then put it down. But if you try to run this, it'll tell you exactly where it failed and why it failed.
Okay, so that's all we have for you this week. If anybody has any questions about your projects or homework or anything about the class, please come up and talk to us. But yeah, have a great week.